Okay, picking up where we left off on 5.5, more on polynomials. Now we can multiply polynomials. So before we're talking about the FOIL method, and we can also square them. Because what does it mean to square something? Exactly. So if you have 5 squared, a lot of people will tell me that's 10, but they're mistaking multiplication of the exponent versus 5 times 5 is 25. So anytime we square something, we're multiplying it by itself. And a big problem when it comes to polynomials, a lot of people will just want to go square x, square y. But if we look at an actual square, okay, so here I have x plus y, x plus y. If we look at an actual square, if I was going to find the area, x times x is going to be x squared, right? Y times y is right here, y squared. Well, what's the area of this piece that has a length of y and a width of x? What would be the area of this square? It would be x times y. And you have another one. Down here you have an x times y. So how many x times y's do you have? 2 of them. There's that 2xy. So this is the reason why x plus y squared becomes this trinomial, which we actually call a perfect square trinomial, PST. You see how it's a trinomial. Whenever we square a binomial, we'll always get a trinomial. Always. It's kind of nice. Okay, so now we can multiply polynomials. We can also square them. Since a power of 2 simply means to multiply by itself, like we were just talking here. Just remember to actually multiply, not just square each term. So this is one of the most common mistakes right here. One of the most common mistakes that I see students make all the time, including in Math 95. So squaring a polynomial, write the product of the polynomial with itself and perform the multiplication. So here we did, when we multiply the polynomial, the binomial, we're going to write it times itself, and remember we get first, that's x times x is x squared. Outside, there's an xy. Inside, there's an xy. Last, there's the y squared. So I just showed you using an area model, okay? Don't fall into the trap of just squaring each term. So like I said, this is the most common mistake. Why is this wrong? Well, if you work out x plus y squared the correct way, you can see the difference above. So that's why a lot of times people will just want to square each one, and they'll only be getting that first term, the FOIL, they'll only do the first and the last, but we have to see that there's those 2 other pieces involved in the square. Okay, so if you're going to square the polynomials, this is not x squared plus 9, right? So let's write it as x plus 3 times itself. And what I would recommend is that you stop and try these problems and then come back to the video and rewatch it. But remembering to always write this out as expanded. Who can tell me what will I get if I FOIL? Plus 6x plus 9. Great. Where did you get the 6x from? Yes. Okay, you have 2 3x's, so that's where you're going to get that sum, the like term 6x. Okay, here for this one, if we're going to square it, let's write it out as 3x minus 4 times 3x minus 4. Oops, I don't know why I wrote 9. Okay, who can tell me what you got when you squared it? Multiplying it by itself. First is going to be good. So that's going to be times, right? 3 times negative 4 is a 12. 3 times negative 4 is another 12. 2 12s is going to make a... Yes. You see how I did that? 12x and 12x, negative. And then the last one is going to be a negative 4 times a negative 4 is a positive 16. Another thing to notice, because we're going to get to factoring pretty soon, is that this starts with a perfect square, it ends with a perfect square. The last term is always going to be positive. Why will the last term always be positive, do you think? Yeah, the signs are the same. A negative times a negative gives you a positive, or a positive times a positive is going to give you a positive. So if I have a negative sign here, that means they were both negative. If I have a positive sign here and a positive sign here, they were both positive. Okay, here we're going to multiply. Now, in the end, I want to distribute. Why can I not distribute the x first? Why wouldn't I distribute that x inside? Yes, and I have to do the order of operations. Remember PEMDAS? This is saying I need to do exponents before I multiply. So I have to do the exponent first. So this is the same thing as x times 3x minus 1 times 3x minus 1. So let's square the binomial first. So we have x times, what's this going to be if I square this whole thing? If I multiply it by itself. 3x times 3x is, good. Then I have another negative 3x, another negative 3x. How many? Negative 6x. I just did two steps in one. And then negative 1 times negative 1 is positive 1. Remembering that it always is going, whenever I square a binomial, I'm always going to get a positive in the end. Now this is telling me to multiply the x times everything. So that means I need to distribute the x to every term. What will it be when I distribute the x to everything? Plus x. What happened to the 1? Oh, it's still there. So if you want, you can write it as 1x. It's not wrong. It just looks weird that way. Okay. All right. So that's all about squaring binomials.